Good evening, students. Today our topic of discussion is very interesting. It is about skin depth and Brewster angle. What is skin depth? It is nothing but the fall of signal strength to 1 by E times of the surface value. Means when the signal travels or the wave propagates into a conductor or a medium, as the wave propagates along the medium, means as it moves on from one point to another, gradually the signal strength becomes weak. So the point at which it becomes or it reaches 1 by E times of the surface value, or at which the amplitude drops to this value, is called as skin depth. Okay. Um, Let us see why it occurs, why this skin depth is caused. It is caused due to the induced currents and energy dissipation within the conducting medium or conductors. It is due to the induced currents and also the uh, dissipation that occurs during the travel of wave from one point to another. So this is mainly occurs in the high frequency applications or high frequency circuits like shielding, etc. How this skin depth can be measured? This can be measured with the help of a formula. Del is equal to 1 by root pi f mu sigma. We know what mu is. It is the permeability of the medium, and sigma is the conductivity of the medium, and f is the frequency of wave propagating, and pi is a constant value. So as the frequency increases, we can easily infer from this formula, as the frequency increases, the skin depth reduces. See here, for example, consider a material copper. If a wave is propagating through a copper medium at a frequency of 60 Hertz, the skin depth is measured as 8.5 mm. If the frequency of propagation is greatly increased to 1 gigahertz, then we can easily identify it is in the order of few microns. So the skin depth is drastically reduced if the wave is propagating with the very high frequency. And what is the major applications of skin depth? It is used to identify the skin effect in AC conductors. Means the conductors have um, rigid material, right? As the wave is propagating through the conductor, and the point at which the amplitude goes below 1 by E of the maximum value, then automatically the signal strength decays. Next is RF shielding. This is high frequency electromagnetic waves, and those waves are blocked by the thin metal layers, right? Okay. Then the next main application is microwave engineering. This is used in calculating all the conducting laws or any kind of losses that occur during the travel of wave propagation, right? Okay. Why the skin effect is mainly considered in AC conductors is the current density is highest, very higher, exactly at the surface of the conductor because of the bulky in nature or rigid material. Right? So next we'll discuss about Brewster angle. What it is actually Brewster angle, and when it occurs or why it occurs? It is the angle. The Brewster angle is the angle of incidence of the polarized light waves, which has zero reflection at a dielectric medium. It has zero reflection exactly at the dielectric medium. This is called as the Brewster angle. When it occurs, or what's the reason for its occurrence? So whenever the wave is aligned with the transmitted wave that causes cancellation, right? Or exactly at the Brewster angle, the reflected rays and the refracted rays are perpendicular to each other, right? So Brewster angle is the angle of incidence when a polarized light has zero reflection. Or at Brewster angle we can define in two ways. Brewster angle is the one which is the angle when there is no reflection, or else you can easily define light at Brewster angle there is no reflected ray and refracted ray, both are perpendicular. And the formula for finding the Brewster angle, theta b, b represents the Brewster angle, tan inverse n2 by n1. For example, we can consider a situation whether the light rays is traveling from air to glass. We know the refractive index is equal to 1.5. Then the Brewster angle can be easily calculated by using the formula tan inverse of the refractive index, which is equal to 56.3. And this is only applied for all the polarized waves. The Brewster angle can be easily applied only for polarized wave. For TE, transverse electric polarized waves, reflection always occurs and therefore no Brewster angle is present there. Right. The main applications of Brewster angle is it can be used in sunglasses and camera filters as polarizers. Polarizers is a function is most important in handling the light rays while filtering or reflecting all those. So polarizers, it is mainly applied in the polarizers where the sunglasses and camera filters are made on this principle. Next is anti-reflection coating, that is on lenses and screens. Whenever we are viewing an object through a lens, we know the lens is a reflecting media, and when we view an object or an image through the lens, if there is any reflection, means we can't view the image properly. Therefore the anti-reflection coating is placed on those lenses, which is used in research or laboratories, right? So that case anti-reflection coatings are used on lenses and screens. Next is for laser beam alignment, and also in wireless communication, wireless and optical communication, and in laser beam alignment using dielectric plates with a reference with the Brewster angle. So the Brewster angle is highly applied for the polarized waves. It is completely suitable for magnetic polarized waves, not for TE waves. Okay. Skin depth is mostly measured or calculated only for conductors. Why? Because within the conductors the skin depth is adverse. It gives worse effect only in conductors. Brewster angle, as I discussed now, it is completely measured within the dielectric medium, whereas the skin depth is measured in conductors. Brewster angle is suitable for dielectrics, and this offers a good shielding, and also it prevents RF loss in optical communication, and it is a good polarization control for sunglasses and screens where a good video or an image has to be recorded or monitored. So what is the need of skin depth and Brewster angle? Um, this is essential for understanding the behavior or to realize the depth and penetration of EM waves which is under interaction with the medium. And it is essential in engineering design like polarizers or any other lenses. Hope you understood this session. Thank you for patience listening. Thank you.